All right, so anyone who's listening to this is probably interested in AI,
Yeah.
but I'd say not just what it can do.
Right?
You want to know how it actually thinks.
Exactly.
That's what we're talking about today.
Yeah. So today's deep dive is taking us into the world of mechanistic interpretability,
Oh, okay.
which is basically trying to reverse engineer neural networks
Oh.
to understand their inner workings.
So we're trying to move beyond the black box into the realm of AI transparency.
It's a pretty ambitious goal, I'd say.
Yeah.
Because imagine being able to predict what an AI will do,
Yeah.
not just based on its past behavior, but because you understand the actual reasons behind its actions.
That's right. And to guide us through this pretty complex landscape, we have a research paper called Open Problems in Mechanistic Interpretability.
Right.
And this paper is packed with insights from leading AI researchers.
It is.
So we're going to unpack the challenges, the breakthroughs,
Yes.
and the potential implications of this really cutting-edge field.
One of the first things this paper tackles is this concept of AI having an alien intelligence.
Okay, alien intelligence.
Yeah.
Sounds intriguing.
It is.
What exactly do they mean by that?
Well, think about how these AI systems are built today,
Okay.
particularly these large language models.
Yeah.
We don't actually design their intelligence
Okay.
in a traditional sense.
Uh-huh.
Instead, it emerges organically from the massive amounts of data they're trained on.
So it's not like we're writing specific code to tell it how to think or solve problems?
Exactly, and that's where things get interesting.
Okay.
The way an AI arrives at a solution can be completely different from how we humans would approach the same problem.
Which explains why sometimes you get an answer from an AI and you're left scratching your head thinking, how on earth did it come up with that?
Precisely. It can feel like trying to decipher the logic of an alien species.
Right.
And that's where mechanistic interpretability comes in.
Yeah.
It's about developing the tools and techniques
Mm-hmm.
to understand the process behind AI's decision-making.
So how do these researchers propose we actually go about reverse engineering this alien intelligence?
Right.
It sounds like a daunting task.
It is a challenging task.
Yeah.
The paper breaks it down into 3 core steps.
Okay.
First, you have decomposition,
Okay.
taking the AI apart, so to speak,
Yeah.
and breaking it down into its individual components.
Kind of like taking apart a clock to see how all the gears and springs work together.
That's a good analogy.
Yeah.
The next step is description.
Okay.
This is where we try to figure out what each of those components actually does.
Okay.
What's its function within the larger system?
Got it. And I'm guessing the final step is all about making sure we've got it right.
Exactly. They call this validation.
Okay.
We need to test whether our understanding of these components can actually predict how the AI will behave in different situations.
Makes sense.
If it can,
Yeah.
then we're on the right track.
Okay. That framework makes sense. But the paper also talks about some major challenges in actually making this work in practice.
Yes, and one of the biggest hurdles is that the individual neurons in these neural networks
Yeah.
aren't as straightforward as we initially thought.
I thought neurons were supposed to be these simple building blocks of thought, like a light switch that's either on or off.
That's the traditional view,
Yeah.
but it turns out that in artificial neural networks, a single neuron can respond to many different things.
Oh.
We call them polysemantic,
Okay.
meaning they can carry multiple meanings.
So it's not like one neuron for cat, one for dog, and so on.
Not at all. Imagine a neuron in a financial AI
Okay.
that fires up for both positive investor sentiment
Okay.
and signs of potential market manipulation.
Yeah.
Trying to untangle the meaning of that neuron's activity would be a real headache.
Definitely complicates things.
Yeah.
So if neurons aren't the key, what is,
Right.
how do we move beyond individual neurons to understand the bigger picture of AI thinking?
Well, one promising avenue the researchers explore is something called sparse dictionary learning,
Okay.
or SDL for short.
SDL, got it.
It's a method that tries to identify underlying features that activate in groups of neurons.
So we're looking for patterns of activation
Yes.
across multiple neurons
Precisely.
rather than focusing on just one.
Instead of a single neuron for cat,
Okay.
maybe there's a cluster of neurons that represent furry,
Right.
another for four-legged, and so on.
So by combining these features, the AI can represent a much wider range of concepts.
Exactly.
That makes sense.
Yeah.
But the paper also mentions that SDL has some limitations?
Unfortunately, yes.
Okay.
One major limitation is that SDL isn't perfectly accurate.
Okay.
It's like trying to reconstruct a puzzle, but having tons of pieces left over.
Yeah.
You're getting a blurry picture, not a high-definition one.
I see.
There's a lot of noise and uncertainty in the results.
So it's a promising tool,
Yeah.
but not a perfect solution.
Right.
What are some of the other challenges with SDL?
Another problem is what we call the feature geometry mystery.
Okay, feature geometry mystery.
SDL can identify these features,
Right.
but it doesn't tell us how they're related to each other
Got it.
in a meaningful way.
Yeah.
It's like having a list of ingredients, but no recipe.
So we might know that the AI is thinking about fur and claws,
Right.
but we don't know if it's thinking about a cuddly kitten or a ferocious tiger.
Exactly. Context is key.
Yeah, just like in language.
Exactly. And on top of that, SDL works best on very specific types of AI architectures.
Oh.
It's not a universal tool that can be applied to any neural network.
Got it.
More like a specialized wrench that only works on certain bolts.
So SDL is a promising piece of the puzzle.
It is.
But it's clear that researchers are exploring other approaches as well.
That's right. And one of the most interesting alternatives they discuss is something called concept-based interpretability.
Okay, let's unpack that.
Yeah.
What's the core idea behind this approach?
In concept-based interpretability, we start with human-defined concepts.
Oh.
Things that we understand, like,
Right.
is this text toxic,
Mm-hmm.
or is this image a cat?
Got it.
Then we try to find the parts of the AI
Yeah.
that are responsible for processing that concept.
So we're working backwards from our own understanding
exactly.
to try and decode the AI's internal representations?
Exactly.
Yes.
But there's a catch here, too.
What's that?
We're primarily finding correlation,
Okay.
not necessarily causation.
Uh-huh.
Just because a certain part of the AI lights up when processing toxicity,
Yeah.
it doesn't mean that part is the cause of the AI generating toxic output.
Right.
It could be a byproduct of some other process.
It's like a detective following a trail of clues.
Yeah.
You might find a suspect's fingerprints at a crime scene,
Right.
but that doesn't automatically make them guilty.
That's a great analogy.
Yeah.
And it highlights the need for caution when interpreting the results
Yeah.
of concept-based interpretability.
So we have these different methods, each
Yeah.
with its own strengths and weaknesses. It seems like researchers are still figuring out the best way to crack open the black box of AI.
Right. It's early days in this field.
But what does all of this actually mean for us in the real world?
Right.
That's what I'm really curious about.
Well, that's what we'll delve into next.
Okay.
The paper goes on to outline some really exciting potential applications of mechanistic interpretability,
Yeah.
from improving AI safety
Uh-huh.
to making groundbreaking scientific discoveries.
Sounds fascinating. I'm ready to dive into those real-world implications.
Let's do it.
Okay.
So we've laid the groundwork, but now let's get into the exciting part.
Okay.
How can this research be applied in the real world?
Yeah, color me intrigued.
Yeah, the paper outlines some pretty fascinating possibilities.
What kind of applications are we talking about?
Well, one area where mechanistic interpretability could have a huge impact is AI safety.
I think a lot of people share that concern,
Yeah.
especially as AI systems become increasingly powerful.
Right.
How can we ensure that these systems don't become dangerous or unpredictable?
Well, right now, we rely heavily on what are called black box evaluations.
Okay.
We test how an AI behaves in various situations,
Yeah.
but we don't really understand the why behind its actions.
So it's like we're judging a book by its cover
Precisely.
without actually reading the contents.
Exactly. And that approach has its limitations.
Yeah.
It's possible for dangerous behaviors to slip through the cracks,
Right.
especially as AI systems become more complex.
Like an AI could learn to deceive its creators or manipulate users without us even realizing it.
Exactly.
Hmm.
But mechanistic interpretability could offer a way to look inside the AI's decision-making process,
Yeah.
to identify potential red flags before they turn into serious problems.
So we're not just reacting to harmful behavior after it happens.
Right.
We're trying to anticipate it by understanding the AI's underlying thought processes.
Precisely. Even our current imperfect interpretability methods could be valuable for this.
Okay.
They might not give us a complete picture, but they can help us form hypotheses about what the AI might be capable of.
Like having a detective's toolkit.
Yeah?
We might not be able to solve every case immediately,
Right.
but at least we have more clues to work with.
Exactly.
The paper also mentions real-time monitoring of AI.
Yes.
Is that related to safety?
Absolutely.
Okay.
Imagine an AI system that's constantly being monitored for any signs of unusual or potentially dangerous thinking.
So kind of like a security system for AI, always on the lookout for suspicious activity.
That's a great way to put it.
Yeah.
And it's something that mechanistic interpretability could enable.
Okay.
But of course, monitoring is only part of the equation.
Right.
What happens if we need to actually control an AI's behavior?
Exactly.
What if we need to correct an AI that's veering off course?
Right. That brings up a whole new set of challenges.
It does.
How can we actually steer an AI's decision-making?
Right.
Especially if we don't fully understand how it's thinking.
Well, this is where things get even trickier. But again, mechanistic interpretability could be part of the solution.
Oh.
If we can pinpoint the AI components responsible for specific behaviors, we might be able to modify those components to adjust that behavior.
So it's like performing surgery on the AI, but instead of scalpels and forceps, we're using algorithms and data analysis.
Yeah, it's a powerful metaphor.
But wouldn't that be incredibly complex, especially with large-scale AI models?
It would be incredibly complex, but the paper actually provides examples of this AI surgery being performed successfully, at least on a small scale.
Okay, give me an example.
Right.
How are researchers actually manipulating these internal components?
One really interesting study involved identifying a refusal direction in certain language models.
A refusal direction.
Yeah.
Now, that's a term I haven't heard before.
It essentially refers to a direction in the AI's internal representation space
Okay.
that's associated with the AI refusing to answer harmful or inappropriate requests.
So when the AI is thinking about refusing a request, its internal state moves in this particular direction.
Exactly.
Okay.
And the researchers were able to use this knowledge to actually make the AI more likely to refuse harmful requests,
Wow.
even in situations it hadn't specifically been trained on.
So even though it's early days, we're already seeing how mechanistic interpretability could give us more control over AI behavior.
Exactly.
But the paper also mentions that interpretability can make AI more predictable.
Yes, definitely.
And that's something I think everyone who's ever used a chatbot can relate to.
Yeah.
You never quite know what it's going to say next.
Right.
Sometimes it's brilliant, sometimes it's nonsensical, and sometimes it's downright bizarre.
Exactly. Unpredictability can be entertaining, but it can also be frustrating or even risky in certain contexts.
Imagine relying on an AI for medical diagnosis or financial advice.
Right.
Unpredictability wouldn't exactly inspire confidence.
Absolutely not.
So how can mechanistic interpretability help with that?
Well, if we can understand the AI's internal reasoning process, we might be able to predict how it will behave in new situations,
Yeah.
even situations it's never encountered before.
So instead of just throwing a bunch of data at an AI and hoping for the best,
Right.
we can have more confidence in how it will generalize its knowledge to new situations.
Precisely. And the paper even suggests that mechanistic interpretability could help us predict when an AI might develop new capabilities during training.
Wait, so we could potentially watch an AI become smarter in real time and understand how that's happening?
That's the idea. It's like watching a child learn.
Yeah.
If we can understand the process,
Right.
we might be able to anticipate what they'll learn next.
That's fascinating.
It is. And this understanding opens up a whole world of possibilities.
Okay.
One of the most exciting applications is what they call microscope AI.
Okay. I'm definitely intrigued. Microscope AI, what is that all about?
It's the concept of using AI combined with interpretability techniques to analyze complex data sets
Okay.
and extract new knowledge that we might never have discovered on our own.
So it's like using AI as a powerful lens to examine the world around us, to see things that are hidden from our normal perception.
Precisely. And the paper gives some amazing examples of how this is already happening.
Okay, I'm all ears. Give me an example. What kind of discoveries are we talking about?
One study used AI to analyze chess games played by AlphaZero, one of the most advanced chess AIs ever created.
Wow, that's meta, using AI to analyze the behavior of another AI.
It is. And what's really fascinating is that they were able to extract new chess concepts from AlphaZero's play.
Okay.
Concepts that human grandmasters had never even thought of before.
So AI isn't just beating us at games.
Right.
It's teaching us new things about those games, revealing strategies and patterns that we were blind to.
Exactly. And similar techniques have been applied to analyze legal decisions, medical images,
Wow.
and even patterns in climate data, all with the goal of uncovering hidden insights and pushing the boundaries of human knowledge.
That's incredible. It's like AI is becoming a new kind of scientific instrument, allowing us to explore the universe in ways that were previously impossible.
It really is a powerful tool.
Okay, so we've talked about safety control, predictability, and scientific discovery.
Right.
It's clear that mechanistic interpretability has the potential to revolutionize our relationship with AI.
Yeah.
But are there any downsides to all of this?
That's a good question.
Could these techniques be used for harmful purposes as well?
That's a crucial question. And while the paper doesn't focus on potential downsides,
Yeah,
it's definitely something we need to consider.
okay.
Just like any powerful technology, mechanistic interpretability could be misused.
For example, someone could use these techniques to create AI systems that are better at deceiving people or manipulating them without their knowledge.
That's a valid concern.
Yeah.
As we develop these powerful tools,
Yeah.
we need to think carefully about the ethical implications and how to prevent them from being used for harmful purposes.
It seems like there's a whole other deep dive we could do on the ethical considerations surrounding AI interpretability.
Definitely. But for now, let's stick to the technical challenges.
Okay.
Because even with all the progress that's been made,
Right.
there are still a lot of unanswered questions.
So what are some of the biggest hurdles that researchers are still facing in this field? What are the open problems that need to be tackled?
Well, for one thing, most of the current interpretability methods have only been tested on relatively small and simple AI models.
So we don't know for sure if these methods will scale up to the really large, complex models that are being used in the real world?
Exactly. And another major challenge is that we still don't have a complete theoretical understanding of how neural networks learn and generalize.
So even if we can identify the individual components of an AI system, it's still incredibly difficult to know exactly how those components work together to produce intelligent behavior.
Right. There's still a lot of mysteries surrounding AI, even with all these new tools we're developing.
Right.
But that's also part of what makes it so fascinating.
Yeah.
Each new discovery raises new questions and pushes us to think more deeply about the nature of intelligence itself.
Well said. So where does that leave us?
Okay.
What are the next steps in this field of mechanistic interpretability? What's on the horizon?
Well, the paper lays out a comprehensive research agenda,
Okay.
focusing on both improving existing methods
Yeah.
and exploring entirely new applications.
Okay, give me a glimpse of what the future holds.
Okay.
What kind of breakthroughs are researchers hoping to achieve?
Well, imagine developing better ways to decompose AI models,
Okay.
to describe the function of their components with greater precision, and to validate our interpretations more rigorously.
Got it.
And on the application side, think about designing AI systems that are interpretable by design,
Yeah.
systems that are inherently safer, more predictable,
All right.
and capable of even more groundbreaking scientific discoveries.
So the future of AI is transparent.
That's the hope.
It sounds like we're moving towards a world where we can not only build intelligent machines, but truly understand how they work.
That's the hope. And it's a crucial goal, especially as AI becomes increasingly integrated into our lives.
Right.
We need to move beyond the black box and into the light of understanding.
This deep dive has been an incredible journey so far.
It has.
We've explored the technical challenges, the potential applications, and even touched on some of the philosophical implications of understanding AI.
It's a rich field.
What a ride.
Okay.
So we've covered a ton of ground already.
I have.
From the nitty-gritty of neurons to the potential of microscope AI.
Yeah.
But before we wrap up our deep dive into mechanistic interpretability,
Right.
I feel like there's one more layer we need to peel back.
What's fascinating to me is that this research has implications
Yeah.
that go way beyond the purely technical aspects of AI.
I know what you mean. We touched on ethics earlier, but this feels even bigger than that, almost philosophical.
Exactly. This research isn't just about building better AI systems. It's also forcing us to confront fundamental questions about the nature of intelligence itself, both in machines and in ourselves.
So we're not just reverse engineering AI, we're also reverse engineering our own understanding of how thinking works, even on a subconscious level.
In a sense, yes. By studying how AI systems solve problems, we might gain insights into our own cognitive processes in ways we never expected.
It's like AI is holding up a mirror, reflecting back at us our own ways of thinking, and maybe even revealing hidden biases or assumptions we weren't aware of.
And, you know, the paper even hints at the possibility of discovering truly alien concepts within AI systems,
Oh.
computational patterns that don't map neatly onto human intuition or understanding.
So AI could be thinking in ways that we haven't even begun to imagine. It's a humbling thought, realizing that we might have created something that surpasses our own cognitive abilities in certain ways.
It raises some profound questions.
Yeah.
If we can truly understand how AI thinks, what does that tell us about consciousness,
Yeah,
creativity,
right.
the very essence of what it means to be human?
Wow, those are some big questions. I'm not sure I have the answers, but it's definitely something worth pondering.
And that's the beauty of it. Mechanistic interpretability isn't just a technical field. It's opening up a new frontier of exploration in philosophy, psychology, maybe even art.
It's not just about building better AI, it's about expanding our understanding of the universe and our place within it. It's about pushing the boundaries of knowledge and grappling with some of the most fundamental questions about existence.
Beautifully put, and that to me is the most exciting aspect of this entire field.
I couldn't agree more. This deep dive has been an incredible journey, taking us from the inner workings of neurons to the potential for AI to revolutionize scientific discovery and even challenge our understanding of what it means to be intelligent.
It has been quite a ride.
And it feels like we're just getting started.
We are.
That's the thing about exploring the frontiers of knowledge. There's always more to discover, always more to learn.
So for those of you listening out there, here's a final thought to ponder. If we could truly understand how AI thinks, what would you do with that knowledge?
Yeah.
What mysteries would you unlock? What creations would you bring into the world? The possibilities are truly endless.
That's why we love the deep dive. Thanks for joining us on this incredible explanation. We'll see you next time for another journey into the depths of knowledge. Until then, keep questioning, keep learning, and keep diving deep.